dear viewer, welcome again to my YouTube channel. Please, if you have not subscribed to my YouTube channel, please try to do so. I will so much appreciate. I'm Mwachukwu Daniel. This morning, we'll be discussing Introduction to Physics Practical. Okay? Very, very important. What do we perform in physics practical? What experiments do we do in physics practical? One of the experiments that a student is meant to perform is experiment on heat, experiment on electricity, experiment on simple pendulum, experiment on optics or light, experiment on moment. Okay, so there are a lot of experiments a student is meant to perform or run in the laboratory with the help of the instructor. Okay, now after running those experiments, after performing those experiments, using the guideline given to you, it is advisable that you get replicate of the readings. That is, if you want to measure a particular value, measure it 2 to 3 times and get the average. Why? To enhance your accuracy and to minimize your error. Okay? Now, after performing your experiment, you are meant to present it on a graph sheet. How do you present a particular experiment or the result of an experiment you just performed? How do you present it on a graph sheet? That is the main point. A lot of students make mistake while presenting on a graph sheet. Now, we have to take these rules or procedures very, very important. Number one, when you bring your graph sheet, as you can see on the board, it is very, very important that you write the date of your experiment. Like today, I write my own date. I can say 2/5/2020, for instance. This is my date of the experiment. Okay? Now, after writing the date of the experiment, you are meant to write the title of your graph. These are the things that has mark. Title of your graph, you say a graph of, don't make mistake of writing a graph of y against x. Please put the quantity you just perform on. Let's assume that they say we should perform on voltage and current. Voltage, the unit of voltage is volts. You put volts. The unit of current is ampere. You put amp. So what you now put here is that since they say plot a graph of voltage against current. So when you say a graph of voltage, you must attach the unit volts against current. Ampere. So you must put the unit along with it. Okay? Now, after putting your title of your graph, it is not a must that your graph must start from 0,0 or from the origin, unless you are instructed to do so. So if you are instructed to plot from from the origin, ensure you plot your graph from the origin. But if you are not instructed to plot it from the origin, please use any scale of your choice. While choosing your scale, ensure you choose appropriate scale. Take for instance now, look at my graph. And this is my y-axis, the voltage, graph of voltage against current, for instance. Now this is my y-axis, it starts from 4. If I start saying 0, 1, 2, 3, 4, 5, 6, 7, 8, you will see that I will jump all this line and start from this point to to start plotting my graph, because you start from 4 to start plotting your graph. You just wasted all these spaces, and it may also make your graph to be squeezed, or your points to be squeezed, not well separated. So if you plot it from here now, you start from 0, 1, 2, 3. The points you have on your graph will not be well separated. And if it is not well separated, it's not a good graph sheet. It's not a good graph plot. Okay? So what you do is advisable if you know that the value did not start from 0. You can say, let me start from 4. If I start from 4, I can say here is 5, here is 6, here is 7, here is 8, here is 9, here is 10. You can see that you will start here to start plotting. And when you start plotting from this point, your graph sheet will be well balanced. Now, it's not a must that you will use 4, 5, 6, 7. But before then, why do you say 4, 5, 6, 7, 8, 9, 10? The reason is because it must be in uniform. If here is 4 and here is 5, 5 minus 4 is 1. The implication is that the next one will be 6, 7, 8, 9, 10. If you come and start writing something like, if you write it this way, maybe you write 5 here, write 7, write 9, write 10, write 11, you see that this is not in a uniform form. That is, 5 minus 4 is 1, 7 minus 5 is 2, 9 minus 7 is 2, 10 minus 9 is 1. So they are not in uniform. So what you do is that you ensure that you use an appropriate scale that will make them to be in uniform. 5, 6, 7, 8, 9, 10. It can work out. If you don't want to use in 1, I mean 4, 5, 6, 7, 8, 9, 10, you can say here is, you can put it this way. Here is 4, here is 4.5. 4.5 minus 4, 0.5. It means that here should be 5. Then here 5.5, 6, 6.5, 7. You can see now 4.5 minus 4, 0.5. 5 minus 4.5, 0.5. 5.5 minus 5, 0.5. 6 minus 5.5, 0.5. 6.5. So they are in uniform. That is, they are in difference of 0.5. So if you come here and you start writing, 4.75, it means that 4.75 minus 4 will give you 0.75. It means that the next one will be this plus 0.75. That will be giving us 5.5. Plus 0.75, that will be giving us 6.25, and so on. What we have achieved is that the difference between here and here is 0.75, 0.75, 0.75. That is what we say it is a uniform. Okay? Now, when you package something this way, when you say, let's say 0.75, 4, as you can see here, the implication is that here is your x and here is your y. This is the starting point of the x Cartesian axis, and this is the starting point of the y Cartesian axis. Please do not interchange it. Do not call here y and here x. That is very bad. So ensure you put x first, then y Cartesian axis. So this is the starting point of x Cartesian axis. This is the starting point of y Cartesian axis. Now, after plotting your graph, it is very, very important that you know how to find your slope. A lot of students do not know how to find slope of a graph. Take for instance, the graph is a positive graph. It moves this way. Your slope, you must put your triangle when you put your triangle, ensure that that triangle cover at least 1/3 of your graph. Then here will be your y2, here will be your y1, here where the vertical and horizontal meet, that will be your s2, here will be your s1. Then if you to get your slope, you say your slope equal to change in y all over change in x. What is change in y? y2 minus y1 all over s2 minus s1. And that will be giving you a positive slope. Okay? Ensure that while choosing your scale, that the scale you choose at least will balance into 10 of your graph. If the scale you choose stop here and the other one stop here, and you have all these spaces left, and you say your graph is like this, that is a very bad graph. Why? Because you have enough space left. So you have to adjust your scale. Adjust it such that at least it will get here and the other one will get here. At least when you plot your graph will be sweet. Your graph will make sense. Okay? Then after getting an appropriate scale, what you now do is you now get your slope. And I've said it now that let the scale you choose, at least let it make sure that your plotting will start close to your zero or for your zero. At least if you put 0, 1, 2, 3, 4, 5, and you are starting from 5 to 4 to plot. If you are starting from 3 to plot, you see that only from here up is what will be covered. Here will not be covered. But if you adjust your scale such that it starts, let's say you are plotting from 4, 5, 6, 7, 8, 9. Ensure from here now you see that your graph will make sense, at least balance well, as I said earlier on. Okay? So when you have a positive graph or a positive slope, it looks this way. But when you have a negative slope, it will look this way. Now, a lot of students make mistake while getting the slope of this graph. Just put your triangle. When you put your triangle, here is your y2 and here is your y1. Now, where the vertical and horizontal meet, that will be your s2. Then this s1. So you now say change in y all over change in s equals to my slope. And change in y is y2 minus y1 all over s2 minus s1. That will be giving us negative slope. Okay? So have this in your mind. Then after plotting your graph, ensure that at least that your straight line that you draw after plotting your graph, that you didn't draw it with your free hand or free sketch. Use your ruler, place it and draw it. And use a well-sharpened pencil. Please, while plotting your graph, use your ruler and a well-sharpened pencil. Don't use free hand sketch. That will make your graph not to be sweet. Okay? Okay. So after plotting your graph, you can be asked to get your slope, the error in your slope, then the intercept on the vertical axis, and error in the intercept. These are questions you can be asked. Yes, because it is noted that none of us is perfect, and because none of us is perfect, we are bound to make mistakes. So we can encounter error while running experiments. But the main point is don't make too much mistakes or don't have plenty errors. Just minimize your error. And this we can do by getting the reading 2 to 3 times and get the average. When you get the readings 2 to 3 times and get the average, then you will minimize the error. Okay? Now, look at the question given to us. We finished running experiment on electricity, and we got these values or these readings. And they said, plot a graph of V against I. Find your slope, intercept on the vertical axis, error in slope, and error in the intercept. For you to do this, all you need to do, remember, write the date of your experiment, the date you perform your experiment. Then write the title of your graph, a graph of voltage, a graph of voltage in volts against current in amperes. After doing that, put your arrow, then put your arrow. Now, our point starts from 4 for vertical axis. If we start putting 0, 1, 2, 3, 4, 5, 6, 7, 8, you see that we will only start from here to start plotting. And while starting from here to plot and go up, you see that your slope will go this way. We have empty space. Empty space. And that will make your work not fine. Okay? Because of that, you have to balance your graph. You have to put it this way. Since to minimize having a bad graph or wrong graph, all you do after putting your arrow, start from 4, because here is 4, 5, 6, 7, 8, 9. That can be a good scale, because the difference between each of them is 1. Okay? Now, in a standard graph, each of these boxes you are seeing is called 2 cm. Each of these boxes you are seeing, these big boxes you are seeing, is called 2 cm. So if you have 4, 5, 6, 7, 8, and they say, what is the scale for this Y part? You say the scale is 2 cm, that is that big box from here to here. 2 cm represents 5 minus 4, 1 unit. The unit of your vertical axis, attach it, very important. So if we say the vertical axis is Y and it has no unit, you just put 1 unit. Then if here is if the horizontal axis is 0, 2, 4, 6, 8, you can see that each of these is called 2 cm. You say for your x, 2 cm represents 2 minus 0, 2. 4 minus this, 2. 6 minus, so they are uniform, represent 2 units. So whatever is in unit of this x-axis, try to clean this unit I put. So if the unit is in cm, clean this unit and ensure that you put it in cm. If the unit of this one is in second, for instance, clean here and put what? In second. 1 second. Okay? Very important. Label your scale very well. Label your graph very well. And it's not a must that you start plotting from the origin. It depends on the type of readings or values you get from your experiment. Now, because our vertical axis starts from 4, we say, okay, to make our graph look sweet, we say this is our x. This is where the x starts from 0.75, 1.5, 2. That is, the x starts from 0.75, 1.5, 2.25, 3.0. So the difference between this and the first value of x, which is this one, the difference between here and here is 0.75. The difference between here and here, 0.75. The difference between here and here, 0.75. So it is uniform. All these differences must be giving you 0.75. If anyone gives you a value that is not 0.75, must give a space so that I will see where it cut the y-axis, where it intersects on the y-axis. So what happened now is that I have to label here and say voltage in volts. And this my x-axis, that is current in ampere. Okay? Now I start plotting. 4 against 1.75. 4 is located here. I'll move like this. 1.75 is around here. I put my point. 4.75 against 3. 4.75 against 3. I'll put my point. 5.25 against 3.5. 5.25 will be around here because this is 5.5, so it will be around here. I will go 3.5. So 3.5 will be around here. I put my point. 5.25. 5.25 against 3.5. 5.25 around here. 3.5 around here. You put. Then 6 against 3.75. 6 should be around here. Against 3.75. So this is where they meet. 6.75 against 5. 6.75 should be around here, but because this is 7 and this is 6.25. So 6.75 should be around here. I move. Then 5. 5 should be around here because this is 4.5 and this is 5.25. So they meet here. Then 7.5 against 5.25. 7.5 should be around here against 5.25. So they will meet here. Then 8 against 6.25. 8 should be around here because it's in between 8.5 and this. Then 6.25. 6.25 should be between 6 and this 6.75. So they will be around here. Then after plotting your graph, you have to take your line of best fit. This straight line I put is called line of best fit. For you to put this line of best fit, ensure that the point that entered on this line of best fit, like here now, how many points entered? We have 1, 2, 3. 3 points entered. After 3 points entered, we have 1, 2 left, 1, 2 left on opposite side. On no account should 2 points. On no account should 2 points. On no account should the number of points that fall on one side be bigger than the one on the other side. Or on no account should all the points fall on one side. If all these points that fall out fall on one side, it's a wrong line of best fit. Then if here is 1, if only 1 fall out this side and 3 fall out the other side, it's a wrong line of best fit. Because at least since 4 didn't enter the line, at least the line of best fit should be so that 2 will fall out one side and 2 will fall out the other side. Okay? So you have to take your good scale so that you can attain these properties we are talking about. Okay? So as you can see, my 2 points fall out this side and 2 points fall out the other side is a good line of best fit. Now, after plotting my graph, next thing is to get my slope. To get my slope, to get the slope of my graph, what do I do? What should I do? I now say, okay, to get it, I put here. I draw my triangle with my ruler. I draw my triangle with my ruler. Then, after drawing my triangle with my ruler, I'll extrapolate the points. So, this is my I2. Then this is my I1. Then Then okay, this is my V2 and this is my V1. Okay, so once you put your triangle, just put your triangle. After putting it, you say change in V and change in current. Get the change in V and change in current. What is your V2? V2, you now say 1, 2, 3, 4, 5, 6. We have it fall at 6. Now, each of these points, how do you get it? See what you do. 4.75 minus 4, that will be giving you 4.75 minus 4, that will be giving you 0.75. Okay? How many buses do we have? From here to here, from here to here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 buses. You say divided by 10. That will be giving you 0.075. So, the implication of this is that what you have is that each of this space is 0.075. From here to here, 0.075, 0.075, 0. So each of the spaces you see, these small spaces is 0.075. So after getting it, what you now do is I say 1, 2, 3, 4, 5, 6. 6 points. Now because it is 6 points, now what you do is that you say each of the point is 0.075. You say 0.075, okay, times 6. What will it be giving you? 0.45. It means that from here to here is 0.45. 0.45 plus 7. That will be giving you that your V2 is equal to 7.45. That is this point. Then your V1 is equal to 4.75. Okay? Now, what you do is that you get your I2. I2 is what? I2 is 5.25. Then your I1 is equal to 3. Okay? Now remember that your slope is equal to change in V all over change in I. And what is your change in V? V2 minus V1 all over I2 minus I1. That will be giving you, what is our V2? 7.45 minus 4.75 all over 5.25 minus 3.00. Now, if you minus, you will be having 7.45 minus 4.75. That will be giving you 2.7. 2.7 all over 5.25 minus 3. That will be giving you 2.25. So, 2.7 divided by 2.25. That will be giving you 1.2. Okay? Now 1.2 what? Because you are plotting the graph of volt against current, don't make mistake and say your slope is just 1.2. Try to attach the unit of your experiment to it. What is the unit of the y? You say volts. Volts. What is the unit of the x? You say ampere. So volts over ampere or volt per ampere. That is the unit. So we have seen that our slope our slope is equals to 1.2 volts per ampere. That is it. The unit is very, very important. Then, after getting your slope, you can be asked to get your vertical scatter. How do you get your vertical scatter? We have gotten our slope to be 1.2. We claim. Then, vertical scatter is noted with W. How do we get it? The highest point that deviated from our line of best fit, use a straight ruler and connect it down parallel to the line of best fit. Then, the highest point that deviated from this side, from the line of best fit, use a straight ruler and connect it. That is this point. Connect it with a straight ruler so that it will be parallel to this line of best fit. Okay? Now, after doing that, what you do is that you now say, let me get the distance from here to what? Here. Vertical scatter, vertical distance. Distance from this line, parallel line to this parallel line. What is this point? This point is this point will be giving us, let's locate it, because you have to use your ruler while doing it. Don't use freehand sketch because you can draw. Use your ruler. Then you see it falls here at the second point. Then what you do is that take out the value out. Take it out. Then this one you extrapolate it to. So what you do, you take out this reading out. Now, how do we get this? Since each of these spaces is 0.075, you say from here to here is 2 spaces. So it says 0.075 times 2. 0.075 times 2. Each of these spaces from here to here is 0.75, from here to here is 0.75. So 0.075 times 2, because we have 2 spaces here. So 0.075 times 2 will be giving us 0.15. Add it to this 7 plus 7. It will be giving us here to be 7.15. Then extrapolate this reading out. You have up to how many spaces? 1, 2, 3, 4, 5, 6, 7. You have 7 spaces. You say 0.075 times 7, because we have 1, 2, 3, 4, 5, 6, 7. So 0.075 times 7, it will be giving us 0.525. Use your calculator. Then you add it to this previous one, 5.5. Okay? That will be giving you here to be 6.025. So what you do is that you say your vertical scatter is 7.15 minus 6.025. Remember, vertical distance from here to here. It can be from here to here. It can be from here to here. Vertical distance from these 2 parallel lines. From here to here, from here to here. Any of this vertical line, take it from here to here. Okay? So when you subtract it, what you'll be having is 7.15 minus 6.025. That will be giving us 1.125. Now, since we got this reading from our vertical axis, we must attach volts, because the vertical axis, the unit is in volt. We have succeeded in getting our vertical scatter. Now, we can also be asked to get Now, we can also be asked to get our intercept on the vertical axis. What is the intercept on the vertical axis? Look at this line of best fit. Look at where it cuts the y-axis. Now, since here is 4.0, here will be 3.25, here will be 2.50, because 2.50 plus 0.75 will give you this. Here will be 0.75. Here will be 1.75. 1.75. So, as it is this way now, this line of best will cut across here. As it cut across here, you say how many points? 1, 2, 3, 4, 5. Now, since each of these spaces is 0.075, remember how we got it? This minus this will give you 0.75 divided by how many boxes do we have? How many small boxes do we have? How many small spaces? We have 10 spaces. So 0.75, which we got from this minus this, divided by 10, gave us 0.075. That has given us the value for each of these small boxes. Small boxes. Each of it has this value. Okay? So what you do is that you now say 0.075, that is for one small box, times how many points? 1, 2, 3, 4, 5. 5 spaces. Times 5. That will be giving us, we now say 0.075 times 5, because we have 5 spaces. That will be giving us 0.375. Okay? We now say 0.375. That is from here to here. We add it to 1.75. We now say 0.375 plus 1.75. That will be giving us 0.375 plus 1.75. That will be giving us 2.125. Okay? And what is the value for that y? What is value for this vertical axis? What is the unit of it? Is in volt. You don't forget to put the unit. Don't forget to put the unit. So after getting it now, we have seen that our vertical axis, the intercept in the vertical axis is intercept on the vertical axis is equal to 2.125 volts. Now we have gotten our slope, we have gotten our vertical scatter, we have gotten our intercept. The next question we can be asked is, get the error in the slope. What is the formula? You say error in the slope is equal to 4 times vertical scatter all over number of plots you have times the range of the x-axis. What do we mean? What is our vertical scatter? We say 4 times 1.125 all over. What is your n? How many points, how many plots do we have? 1, 2, 3, 4, 5, 6, 7. We have 7 plots. Then RS means range in the horizontal axis. That means the highest, RS equals to the highest in the horizontal, 6.25 minus 1.75. Now 6.25 minus 1.75. That will be giving us 4.5. So you put it here times 4.5. That is your range. That will be giving you, you now say, when you multiply 4 times 1.125 in bracket divided by 7 times 4.5. That will be giving us 0.143. Now, this is our error in the slope. And what is the unit? Since it is error in the slope, the unit will be volt per ampere. So 0.143 volt per ampere. Okay? Now, what you now do now is you are getting the error in the slope. The next one is get the error in the intercept. Get the error in the intercept. To get the error in the intercept, you say use the formula error in the intercept. Error in the intercept equals to square root of W vertical scatter all over N all square plus error in slope times mean of the value of x. Okay? Now, all squared. So you now get square root of everything. Now, we know, let's package it well. Now, you know that your W is equal to 1.125. Our W gave us 1.125. Okay? Then our error in slope gave us 0.143. Okay? Now, how do we get our mean of x? Mean of x simply means add up all the values of horizontal axis. 1.75 plus 3 plus 3.5 plus 3.75 plus 5 plus 5.25 plus 6.25 all over 7. 1, 2, 3, 4, 5, 6, 7. So, when you press it in your calculator and you divide, that will be giving you 4.07 to be the mean of x. Okay? Now we have gotten our mean of x, we have gotten our n, and n equal to 7. We have gotten our SG equal to 0.143. Okay? Then we have also remember our error in the intercept is what we are getting now. Now we have gotten our SG to be 0.143. We have gotten our W to be 1.125. Okay? Now what we do is we will plug it into here. Okay? Now when we put it, see what we'll be having. You will be having, we say that our mean is equal to 4.07 and our n equal to 7. So we'll be having square root of, what is our W? W is 1.125. 1.125. This is 7.15. So our W is 1.125, all over our N is 7, all squared, plus what is our error in slope? 0.143 times mean of the value of x-axis, then is 4.07 all squared. Now you use a very healthy calculator to package it. Now I'll package my own. So give me bracket 1.125 divided by 7 all squared plus bracket 0.143 times 4.07 bracket raised to the power of 2, close the bracket. So when you finish putting it, it will be giving you 0.604. Then what is the unit of error in the intercept? What is the value of your intercept? You say volts. So from this, we have succeeded in getting the value for our slope. Value for our slope gave us 0.143 volt per ampere. Value for intercept on the vertical axis is 1.75 plus 0.375. 2.125. Error in the intercept gave us 2.125 volts. Then error in slope gave us 0.143 volts per ampere, because we plotted the graph of V against current. Then that is why we put the unit this way. The error in the intercept gave us 0.604 volts. Why didn't we say volt per ampere here? It's because the intercept is on the vertical axis only. So it will only take the unit of the vertical axis. Okay? That is the answer. Then the implication of this is that after getting your values, you can package your answer this way. You say your slope is equal to, what is our slope? 0.143. Then, no, our slope gave us, this is error in slope, please. So this is error in slope. So our slope, when we got it to be 1 point something. I've cleaned it off. But note that your intercept is equals to 2.125, then plus or minus error in the intercept 0.604 volts. Then for your slope, to write your slope, we write the actual value of slope we got plus or minus the error in the slope, 0.143 volt per ampere. So you have to package this way because this is the error encounter while getting your slope, and this is the error you encounter while getting your intercept. So to plot your graph very well, ensure you use a well-sharpened pencil and a ruler so that you get all these values we got. Okay, thanks for watching the video. You will see the second part of this practical in physics, and don't forget to subscribe to our YouTube channel and turn your notification button on so that you keep in touch with our videos that will come up. Thank you.